In this demo, we'll take a look at how we can augment our item order skip navigation by adding a payload to the join entity. We'll do so by implementing a C# class that will be mapped to the item order join table. And then we'll extend that class with a few properties. First, we'll add an order date property, which will give a default value. As mentioned, this is often how such payloads are used. And secondly, we'll add a quantity property to track how many items are contained within an order. Before we get started on the demo, let's just quickly look at the code that we'll use to implement our new item order entity. What we see here is a simplified version of the entity that we'll be using for our skip navigations. As we can see, it contains the basic properties which are needed to create the many-to-many relationship, which are the items ID and orders ID properties. It also contains navigation properties for the corresponding item and order entity to make them easier to access. And finally, it contains the order date and quantity properties, which constitute our payload. And now let's get started on the demo. We're now back inside Visual Studio, and we're looking at the item order entity that we'll use to map to the item order table so that we're able to add a payload to our skip navigation. As we can see, the entity contains the ID fields that are needed to create the foreign key relationships to the orders and the items tables. We can also see that it contains two navigation properties for convenient access to the order and the item instances that the individual item order entities relate. Furthermore, it contains the payload data, which we discussed during the slides. Here we see the order date, and here we see the quantity. And now let's head over to the database context, where we set up the skip navigations on the order and the item entities to use our new class. We do so here where we set up the order entity. We could just as well have done it on the item entity instead, but we only need to do it on one of them, so we randomly chose the order entity. What we do first is to define the many-to-many relationship by specifying that the order entity has many items, which in turn have many orders. If we stopped here and created a new migration, it would be empty, since this is just explicitly stating what EFCore has already done for us. But by adding the next bit of code here, where we call the using entity method and passing in the item order class as the generic input parameter, we tell EFCore to start using this class instead of the property back entity it had created for us. This method takes several functions as input, which we define in the lambda statements that we see here. What we do here is to set up the item order in a way that is very similar to how we shall soon create an indirect many-to-many relationship. First, we specify that the item order has one item, which has many item orders, and that the items ID property must be used to contain the foreign key for this relation. Secondly, we specify that the item order entity has one order, which has many item orders, and that the orders ID property must be used to contain the foreign key for this relation. So these two functions together define the left and the right side of the many-to-many relationship. The third input parameter to the using entity method is an action which is used to configure the join entity. In our case, we passed in an anonymous function where the first thing that we do is to specify that the key of the join entity is made up of the combination of the items ID and the orders ID. If we had done nothing further, and we hadn't added the order date and quantity properties to the item order entity, creating a new migration would once again result in an empty migration class. This is because all we would have done was to tell EFCore to stop mapping the item order table to the property back entity and instead start using the item order entity. Since that entity would then have had only fields corresponding to the columns found in the item order table, no changes would have been necessary on the database. But we did add those extra properties, however, and in the next bit of code that we see here, we also set up a default value for the order date property, which we set to the current timestamp on the database by calling the current timestamp function. If we now create a migration based on this, we can see that it only contains changes related to the two columns that we wish to add to the item order table. This is actually very powerful, and it helps us easily transition from a skip navigation that utilizes property back entities to one that uses a proper join entity such as our item order entity. Here we see the order date, which is mapped to a datetime2 type and is given the default value that we just specified for it. And likewise here we see the mapping to the quantity, which is mapped to an int type. Note that since this is a non-nullable int, it is given a default value of 0. Just like we did with the order date, we could have specified another default value. But since we did not, EFCore defaults to setting it to 0. Also note that when we look at the order and item classes, we see that the navigation properties that we define for them are unchanged, and they do not use the new entity that we just created. This means that if we want to fetch the items within an order, we can do so just like we did before. We only need to change our code when we want to deal with the quantity or the order date, as we've already talked about. The reverse, of course, is true for the item class. And now let's apply the migration to the database and head over to the program class in the console application and see how we can fetch item orders using our new entity. In this demo, we'll take a look at how we can interact with the payload that we just added to our join entity. The code that we see here is very similar to what we just saw when we fetched the skip navigations before we started to use the item order entity. And once again, we start off by fetching all items contained in the order with ID 1, just to see that we can still use our skip navigation properties in the same way that we did before. The next thing that we do in this bit of code here is to fetch the skip navigations for the order entity like we also saw in the previous demo. And this next bit of code here once again fetches the skip navigation corresponding to the items collection, this time simply by taking the first entry since we know that there will be just the one. And after this, the bit of code that we see here fetches the database set that contains the item order entries. Once again we access a database set which we haven't set up ourselves, but which EFCore has created for us. This time we pass in the item order entity as the generic input parameter, since we can no longer use the dictionary of string and object type now that we've told EFCore to map the item order table to the item order entity. And the following block of code here interacts with the payload on our join entity. The first thing that we do is to fetch the first item order from the item order set that we just created. Then we read the order date from the returned item order. Since we've just introduced this field, we would expect all entries in the item order table to have the same order date, which will be set to the time on the database when we applied the migration. Next we read out the quantity, which we expect to be 0, since that is the default value of that column. After this, we first set the order date to be the 1st of January 2020 on the item order instance, and then set its quantity to 10. And after this, we save the changes to the database. Before we run the code, let's quickly take a look at the contents of the table in the Server Explorer. Here we see the 5 item order instances. And as expected, we see that they all have the same order date, the 12th of November 2022, and the quantity 0. Now let's head back to the program file and try to run the code. If we step past the first bit of code here, we can once again take a look at the items that were returned here in the watch view. And as we can see, we once again get 2 items back. And if we expand the first one, we can see that it is once again the item with ID 1, and the second one is the item with ID 2. If we now take one more step with the debugger, we fetch the list of all the skip navigations on the order entity, and as we saw previously, it just contains one skip navigation, which we can expand, and see that just like before, it's the skip navigation for the items collection. If we now take a couple more steps with the debugger, we first fetch the item skip navigation, which is the first and only entry in the collection, and we then fetch all the item order entities by calling the set method on the database context and passing in the name of the skip navigation. If we now take a look here in the watch view, we can see once again that we have fetched 5 item order entities. But this time they are not instances of dictionaries of string and object, but rather instances of our new item order entity. If we expand the first one, we can see that it relates the item with ID 1 to the order with ID 1. And we can also see that the order date is the 12th of November 2022, just like we saw in the database, and that the quantity is 0. And if we expand the second entry, we see that it relates the item with ID 1 to the order with ID 2, and it has the same order date and quantity as the first entry that we looked at. If we now move the debugger past the next bit of code here, we fetch the order date and the quantity from the item that we just fetched in the exact same way that we would do for any other entity. And as we can see, it has the order date and the quantity that we would expect it to have. If we now move the debugger a little further past this bit of code here, we will update the order date and quantity of the item order that we fetched and save the changes to the database. If we now head over to the Server Explorer, we can see that the first entry now has the order date 1st of January 2020, just like we set it to in the code, and it has the quantity 10. In the demos that we just saw, we first learned how we can interact with the join entity that EFCore has created for us under the covers to implement the skip navigations for the direct many-to-many relationship between orders and items. What we saw here was that even though we don't necessarily think about it, EFCore will indeed create an entity to implement this relationship, and it does so by using property back entities. As we discussed, skip navigations offer us many advantages, since implementing them is very simple from a coding perspective, both in terms of setting up the relationship and subsequently interacting with it in our code. But skip navigations also have limitations. The biggest one being that we are not able to add payload data to the join table, which would allow us to add additional relevant information to the join. So after having seen how we can interact with the join entity that EFCore has created for us, we saw how we could create an explicit join entity class and use that to add payload data to our skip navigation. This enabled us to fix the problem that we had with our relationship between orders and items, and we saw how we could both fetch and update the payload data stored in the individual instances of our join entity. Now that we've created a join entity to contain the payload for our skip navigations, creating an indirect many-to-many relationship between items and orders is a relatively simple procedure. The first step in this is to replace the skip navigations on our item and order entities with navigation properties that use our new join entity. Of course, creating the relationship is only part of the story, and actually using and managing the relationship is probably where we will be spending most of our time as we're interacting with this new mapping. And as we shall soon see, the indirect mapping is not quite as user-friendly, or rather coder-friendly, as the direct mapping is. This is because with the indirect mapping, we'll be dealing with two levels of relationships, one between the item and item order entities, and the other between the order and item order entities. And also, unlike when we used the join entity with the skip navigations, using it to create an indirect many-to-many mapping will force us to make changes to the code that accesses our two payload properties, the order date and the quantity. But depending on how often we interact with these properties, that change might well be worth the effort, because it will allow us to do away with the somewhat convoluted approach that we had to take to access our skip navigations, and instead access the payload data directly from our item and order entities by using the join entity and its properties to access the relevant data.